Hi everyone, in this video we're going to be continuing with 6J, which is the tangent function. We're going to focus mostly on solving equations, and it's not too different to solving sine and cosine functions. So if you're okay with that, you're probably fine with tan, but it's also a good revision for sine and cosine functions or solving sine and cosine functions. We're also going to graph some more tan functions because they pop up in question 7, but also looking at the relationship between tan and sine and cos in question 11, which is going to be useful. All right, I don't want to make this a long video, but I have a feeling it might be because there's a lot going on. This top diagram probably isn't in your notes because I didn't give it to you. But you do need to remember exact values. So you either remember the table or you use the triangles to help you remember. So with these triangles, basically we have one triangle, an isosceles triangle. So you can see you've got two angles the same, two sides the same. As long as you can remember these numbers, you should be fine. And just remember also that 45 degrees is the same as pi on 4 radians. Now, we don't work with degrees in methods, so don't go leaving your answer in degrees. All right, the second triangle is an, what is it called, a scalene? All right, so we've got two angles that are different and these two sides are different. So however you remember this triangle, you can actually work out these values using Pythagoras' theorem. So let's say you remember the hypotenuse is 2 and the side alongside the 60 degrees is 1. You can always use Pythagoras to find the other side. Or you could use your trig ratios because this is just trigonometry at the end of the day. 30 degrees is pi on 6. 60 degrees is pi on 3. And you can do 90 degrees if you want, that's pi on 2. And a full pi is 180 degrees. And 2 pi is 360. So these values you can also get from the unit circle. So knowing that we start our unit circle at 0 and a full rotation is 2 pi. So that means pi must go there. Pi on 2 must go here. 3 pi on 2. Now, if pi on 2 is 90, then half of 90 is 45, and half of pi on 2 is pi on 4. So there's many ways you can remember the relationship. I do think the triangles are the best way, or if you can remember the values in the table. Okay, so for question 4, we're going to be solving some equations. I'm only going to do 2 because I don't want this video to go on forever. But if you got this sort of question in exam 1, you do need to know your exact values. So don't think, oh, I don't need to know them. You do need to know them. The 2 that I find the easiest to remember, or the 3 actually, are these values here, 45. It's just, I always say root 2 on 2, so I rationalize the denominator, but it's the same as 1 on root 2. And because tan theta is equal to sine theta on cos theta. All right, that's where the 1 comes from. So root 2 on 2 over root 2 on 2 is 1. All right, and then the other values, you can see the relationship between them. Okay, and that's because if you're working with 60 degrees, your opposite side, which is root 3, is the same as the adjacent side for 30 degrees. So that's why they look quite similar there. Anyway, let's get started on doing some questions. So I might do one positive and one negative. So I'll start with question A as a positive. And what I mean by positive, solving for a positive answer. So we've got tan 2x is equal to 1. And we've got the domain of 0 to 2 pi. For the rest of them, we're going from negative pi to pi. So it's probably good that we're doing an example of 2 different ones. So x is an element of 0 to 2 pi. Now the reason we have curved brackets is they're probably asymptotes. Okay, so they're not included. When we're doing our solutions, we do need to take note of whether there's a coefficient of x, because our domain, we're effectively looking at x between 0 and 2 pi. But when we're looking for solutions, we tend to just solve for 2x because it's easier. And when we solve for 2x, we do need to multiply both ends by 2. So we're going to go from 0 to 4 pi. We're not changing our domain. So when we get to the end and you see the solutions, you'll see that I haven't changed the domain, but just changing your values from 0 to 4 pi means when we're looking at our solutions on the unit circle, we're going from 0 to pi to 2 pi, then to 3 pi, then all the way back to 4 pi. All right, instead of just going from 0 to 2 pi, it helps us find our solutions. Okay, so let's get started. So let's solve for 2x. So if I just take inverse tan of both sides, 2x is equal to, no, I'm just going to cheat, tan 45 is equal to 1, and I'm not dealing in degrees, so I'm going to write pi on 4. So 2x is equal to pi on 4. Just before we start looking at our solutions, we need to decide which quadrants we're in. So because our answer is positive, we're going to be in the first and the third quadrant where tan is positive. And remember, we go in an anti-clockwise direction. So our first solution is actually going to be pi on 4. So 0 plus pi. So I probably should have written this here. So therefore, our basic angle is pi on 4. Okay, so I'm going to do the solutions, including x, so pi on 4. All right, so 2x, first solution, 0 plus pi on 4. Our second solution, we go around the unit circle until we get to the next quadrant our solution is in. So it's in the third quadrant, so it's going to be pi plus pi on 4. And then our next quadrant, we keep going around the unit circle until we get to 4 pi. So 2 pi plus pi on 4. And then around again to 3 pi plus pi on 4. And then I get to 4 pi. I can't go any further because then I'm going to be outside the domain. All right, so just to tidy it up, I'm going to put everything as a mixed number fraction, not a mixed number, sorry, an improper fraction. So currently they're not added together. So 0 plus pi on 4 is just pi on 4. Then we've got pi plus pi on 4. Now you can convert all your pi's to 4 pi on 4, just so we've got the same denominator, and sometimes my brain doesn't do what I want it to do. Okay, so 4 pi plus pi is 5 pi on 4, and then 2 pi is going to be 8 pi on 4. So this is going to become 9 pi on 4. And then 3 pi becomes 12 pi, so 13 pi on 4. What else was I going to say? Okay, you'll notice the difference between all our solutions is actually pi. Okay, so 4 pi on 4. So we're adding pi each time, and that's because the difference in your quadrants is pi. All right, so basically we are here and we're here. So if we were to go from here to here, we've gone half a circle, so it's going to be pi. So we're adding on pi each time to our solution, basically. You don't really need to remember that, but some people like to see those little tricks that can help them find the solutions. All right, so we need to solve for x. So to get rid of that 2, I'm just going to be multiplying it by a half It's the same as dividing by 2, but sometimes it's helpful to see when you're dealing with fractions to multiply by half or whatever the reciprocal is. Okay, so those cancel out, the 2's cancel out, or the half cancels out with the 2. So then we've got pi on 8, 5 pi on 8, 9 pi on 8, and then 13 pi on 8. And you'll notice now that we are within our domain, which is here. Okay, so if it helps, you can rewrite that domain with a denominator of 8. So 2 pi is the same as 16 pi on 8. So you can see I am within the domain for all those solutions. All right, let's move on to a negative. So I'll do question C. So negative root 3. So we basically are doing pretty much the same thing. We're going to have a different basic angle, and because we've got a negative answer, we are going to look at a different spot in our unit circle. And I just remembered we are doing a different domain also. So x is now going between negative pi and pi. So if I wrote that as an inequality, that's going to be negative pi to pi. So because we've got 2x here, I'm going to just change it to 2x. So what I do to that x is I've multiplied it by 2. So we multiply everything by 2. So we're going to go from negative 2 pi to 2 pi. So with my unit circle, I'm going to start at negative 2 pi, and it's a bit too thick, so I'm going to change it to this. Negative 2 pi, and I'm going to be at negative pi, then at 0, then at pi, and then at 2 pi. Okay, so going around the unit circle in an anti-clockwise direction. All right, let's find our basic angle before we start discussing which quadrant we are in. Okay, why did I do y equals? That's me trying to remember and remembering incorrectly. Okay, so let's just take inverse tan of both sides. All right, so 2x, inverse tan of root 3, let's just go up here. So that's going to be tan 60, and 60 degrees is pi on 3. And it is negative because we've got the negative here. But we just need to find the basic angle. So the basic angle we can just do as positive pi on 3. All right, and because we're looking at a negative, we are going to be in the second and the fourth quadrants. Okay, so the previous example, we're in the first and the third because that's where tan is positive, but tan is negative in the second and the fourth quadrant. So we're looking for solutions there. We're going to keep it as 2x for now. Okay, so 2x equals. So our first solution is going to be negative pi. So we're in the second quadrant, so negative pi, and then we've got to go back to pi on 3. So remember, our solutions are always taken from the horizontal. So we're basically going here at negative pi and then going back pi on 3, sorry. Okay, our next solution is going to be in the fourth quadrant, so that's going to be 0 minus pi on 3, and you can see now we've got that negative pi on 3, and then we're at pi minus pi on 3, and then 2 pi minus pi on 3. And you'll notice the difference between them again is going to be pi because the quadrants are opposite each other. All right, let's just bring everything over the same denominator. So negative 3 minus 3 is negative 4 pi on 3, negative pi on 3, 3 pi, 2 pi on 3, and then 6, 5 pi on 3. Okay, so we've got the 2 in front of the x, so we do need to get rid of that. We can just multiply by the reciprocal. You'll notice that doing this, the denominator just doubles basically. So we're going to cancel them out, and that means x is equal to negative 4 pi on 6, negative pi on 3, nope, sorry, I'm getting ahead of myself, I was thinking of something else, 2 pi on 6, and 5 pi on 6. So what I was thinking about, sorry, is you can actually simplify these. So we should, instead of write negative 4 pi on 6, it should be negative 2 pi on 3, just simplifying that fraction, and 2 pi on 6 can become pi on 3. Now, just to check if you want to see whether they fit into the domain, so we're going from negative pi to pi, which is the same as negative 3 pi on 3 to 3 pi on 3 if you want them as the same denominator. And, oops, I should change it to 6, sorry. Same thing, but I forgot that my denominator was 6. So you can see we're going from negative 4 pi on 6, which is greater than negative 6 pi on 6, to 5 pi on 6, which is less than 6 pi on 6. So we're within our domain. All right, I find solving trig equations quite, if you follow the method, and you do need to know your exact values, you should be fine. Like, it's just a matter of finding that basic angle and using your unit circle to find the solutions. If you don't have x, if you got 2x or 3x, just making sure that you take that into consideration. But yeah, they're quite rewarding when you get to the end because they can be quite tedious. All right, now we've already done some sketching in the previous video, but this time, instead of just having a horizontal translation, we've got a vertical translation as well. So let's just keep in mind our domain. So remember, with tan graphs, we do have asymptotes. So you'll notice that often curved brackets will be used. Okay, just to denote that there's probably an asymptote at x equals 0 and an asymptote at x equals 2 pi. But not necessarily always going to be the case. All right, I might do question A first, and then we'll do maybe question C. So y equals 3 tan x, whoops, plus 1. Now there is a big difference whether I ended the bracket there at the x or after 1. Okay, so let's consider what the features of this graph are. Okay, so it has been shifted up 1. It's gone up 1. It hasn't gone left or right. We do have a dilation of factor. I never write these correctly. Dilation of factor 3 from the y-axis. So that's what the 3 tells us. In tan graphs, we don't have an amplitude. Okay, so that's just for sine and cosine graphs. Your value of n helps you find your period. So we did this in the previous video. So the period for a tan graph is different to a sine and cosine graph. It is pi on n. Don't want a comma there, sorry. I'm so used to writing solutions. So in this case, n is 1, so it's just going to be equal to pi. What else do we need to do? Nothing, I don't think. The amplitudes, not the amplitude, I always get my amplitude and the asymptotes mixed up. All right, 2 very long A words, but we want asymptotes. All right, so the formula for the asymptotes is given to you at the start of the notes for 6J. So they're at x equals 2k plus 1 pi over 2n. So in this case, n is equal to 1. So that's going to be 2k plus 1 pi over 2. Now, when you're finding your asymptotes, you do need to take into consideration your domain. Okay, so our domain is from 0 to 2 pi. So remember we need to look at different values of k. So what we've got here is a general solution for your, or general equation for your asymptotes, and k is just an integer. So you can say, all right, I'm going to let k equal 0, maybe 1, 2, we'll see how we go. So I'm just kind of setting up a table here, so we don't have to keep writing things down. Okay, so when k is 0, we're going to have x is equal to pi on 2. And then when k is 1, we're going to have 3 pi on 2. Not 3 pi on 3. 3 pi on 2. And then when k is 2, we're going to have 5 pi on 2. And you'll see I'm only supposed to be going from 0 to 2 pi. There hasn't been a horizontal shift, so these are our asymptotes, except for the last one because we're now beyond our domain. Okay, so that's not going to be an asymptote. So we have asymptotes at x equals pi on 2 and x equals 3 pi on 2. We do need to look at our endpoints though. Okay, so our endpoints aren't going to be asymptotes, they're going to be points. So we do need to take them into consideration, so I might do them now. So endpoints, so first one is at x equals 0. So when x equals 0, what's tan 0? All right, tan 0 is 0. So when x equals 0, y equals 1. And when x equals 2 pi, y is also going to equal 1 because we're at the same spot on our unit circle, 0 and 2 pi. So when I'm sketching, remember you're going to have open circles because your domain is not including 0. So we're going from, so the point is at 0, 1 and 2 pi and 1. Now that's a bit confusing because they're supposed to be open circles, but anyway. And the other thing we need to do is our x-intercepts. Now, because these graphs, we haven't had a horizontal translation, but we have had a vertical translation. So we do need to do it a little bit differently to how we did it in the previous video. So for our x-intercepts, we just let y equals 0, okay, as we do for any function. So I'm just going to put that so I can see it. So we're going to have 3 tan x plus 1 equals 0. And then we're just going to solve for x within our domain. Okay, so let's just quickly do that. So tan x equals negative 1 on 3. So x is equal to negative inverse tan 1 on 3. All right, I think that's pi on 3. Pi on 6. No. Oh no. All right, so we don't have exact values for that, so that's fine because we'll just then have to use our calculator. All right, so let's just do that on the calculator. What do we got? 1/3. All right, so you'll notice it doesn't matter that I didn't put the negative in, but all right, negative 0. Now you can check if there's an exact value, so maybe I should do that first, but I'm pretty sure this is going to write the same thing for me. Sorry. Okay, so we'll just leave it as decimals. 3, 2, 2. All right, so on our, since we now have to use the calculator, what we can do is just to solve. All right, so if we want to get all the solutions, I'm just going to use solve, and we can just go tan x equals -1/3 and comma x, and we need to restrict the domain, otherwise we're going to get a general solution. So given that, so x is between between 0 and 2 pi. Try it again. All right, so you can see your solutions there. Now you will also notice, which I didn't pick up before, the solution I wrote down before was not within our domain. So not in domain. All right, so you can, if I just write down the actual solutions, we got, now why did it do the bigger one first? 2.82 and what have we got? 5.96. All right, so let's sketch it quickly because it's becoming a very long video. I might just do it on the side here. All right, so our asymptotes, actually we're going from all the way to 2 pi, so I'll put that in first. All right, so our asymptotes are at pi on 2 and 3 pi on 2. And my endpoints are at 0, 1. So it doesn't really matter where you do that. Let me just think. 0. An open circle there. Sorry, I just had a bit of a mind blank. And an open circle here. All right, so we use open circles because our domain is not including 0 or 2 pi. Now with my x-intercepts, we're going through 2.82. So don't know roughly where that is, but if I just do on my calculator pi on 2, which is 1.5, and if I do half that, we'll know what the halfway point is, so pi on 4. So we're going to be, oops, we're not crossing there, that's my fault. All right, so we'll do pi on 2 plus pi on 4. Actually. So we're just getting the halfway point between our, which is pi. All right, sorry, I got mixed up with, oh my God, the y-axis and the asymptote. Okay, so your first graph, let's just sketch that first. So we know the shape of the tan graph, so this basically is going up like that. Now, our x-intercept, so the 2.82, if we look between our two asymptotes, we've got pi in the middle and we know pi is 3.14, so it's going to be crossing to the left of that. All right, so kind of like that. And then for the next one, we're at 5.96. So it's kind of crossing at the same distance from that midpoint. And we're going to be stopping there at 2 pi. All right, let's move on to question C. So in C, we've got a horizontal and a vertical translation. Let's see if we've got enough space here to do it. Probably do. Okay, so question C, can't remember what it was. Y equals 3 tan 2. Now, I think that's what it is. Let's just double check. Oh, it's minus 2. It's all good. All right, so when we think about the transformations for this one, there's my dog scratching in the background. Okay, so the minus pi on 4 means we've gone to the right pi on 4. The minus 2 means we've gone down 2. And the 3 means we've had a dilation factor of 3 from the x-axis. I'm not going to write that down because the other transformations are going to help us with sketching our graph. Actually, the vertical transformation doesn't make any difference, but remember the pi on 4 does. Okay, so I'm going to sketch first of all. Not sketch, but I can't do anything until I've got my asymptotes. Now we can sketch it on the calculator, but I'm going to do it by hand. So we've got y equals 3 tan 2x. So I'm just going to deal with that one without the transformations first, just to get our asymptotes. Okay, so use to get asymptotes. The minus 2 doesn't make any difference to your asymptote, so we're just going to look at 3 tan 2x. The 2 does make a difference to your asymptotes. Okay, so let's do the period first. So the period is going to be the same for both, the pink and the green. Okay, so remember the period for a tan graph is pi on n. So n in this case is 2, so it's just going to be pi on 2. And that means your asymptotes are going to be x equals 2k plus 1 over 2n, and I always forget the pi. And what does that even look like? Let's just tidy that up a little bit. 2k plus 1. That's a bit better. Okay, so n is equal to 1. So we're going to have 2k plus 1 pi over 2. Oh no, n is equal to 2. Sorry. Let's just fix that up. So that should be our 4. Just make sure that is all good. Okay, so we can set up a table like we did before to get our asymptotes. So I'm going to do 0, 1, 2. Just wondering if we need to do -1. Maybe I'll do -1 just for the fun of it. I don't really need 2 though, because 2 is going to take me out of my domain. But I'll do it anyway. 0, 1, 2. You can put any values of k, but you don't really need to do many, really around 0. So just stick to the ones around 0. Okay, so when k is equal to -1, 0, 1, and then we'll do 2. All right, so substituting them into your asymptote formula. So first of all, we're going to have -1 times 2 is -2 plus 1 is -1, so negative pi on 4. Then the 0 is going to give us pi on 4. 1 is going to be 3 pi on 4. And then 2 is going to be 5 pi on 4. Okay, now they would be our asymptotes for this green equation, but because we've got this transformation, pi on 4, we do need to add pi on 4 to each one. So add pi on 4. Okay, so that means our asymptotes are at x equals, so negative pi on 4 plus pi on 4 is going to be 0. Pi on 4 plus pi on 4 is 2 pi on 4, or pi on 2. Then 5 pi on 4. And then, what is that, 6 pi on 4? Now, I just realized that we are going to be using that 6 pi on 4 because it's still within our domain. I'm going to keep everything with a denominator of 2. Sorry, not a denominator of 4. I just want to show you, let's just do 3, just because I did want to cross one out. All right, so in k equals 3, we're going to have 7 pi on 4. And remember, we've got the transformation, so we're going to be adding pi on 4. So that means we're going to have 8 pi on 4. Actually, we've got 2 that are going to be our endpoints. So x equals 0 and x equals 8 pi on 4, both asymptotes, but they also are the endpoints of our domain as well. So we don't really need, or we should still sketch them on our graphs as well. So our endpoints, which I might continue under here, endpoints are going to be at x equals 0 and x equals 2 pi. All right, so when x equals 0, y is equal to, oh, sometimes I really just can't be bothered doing this. So let's just do it on the calculator. So we've got 3 tan 2x. So 2 times 0 is 0. And then 2 times pi on 4 is negative pi on 2, sorry. When I do long videos, it can be exhausting. So I've got minus 2, and I should really do the exact value if it's going to give me an exact value. Negative 5, awesome. So that tan pi on 4, oh, that's 1. There we go, negative 5. Oh, that's good. I probably could have done that. All right, and same for that one. All right, have we done everything? Oh, our x-intercepts. I'm running out of room, guys. I'm going to have to go over the page. All right, let's do our x-intercepts. I know you can hear my dog in the background. She just grunted. So, oh, x-intercepts. All right, so x-intercepts, let y equal 0. Now, because we've got the vertical translation, the negative 2, we can't use the k pi on n like we did for question 3. Okay, so your x-intercepts are going to change, so we just let y equal 0. So we're going to have 3 tan 2x minus pi on 4 minus 2 equals 0. All right, let's just solve a little bit of this. All right, so it's going to be 2 on 3. And then, yeah, let's just solve on the calculator. It's not going to give me exact values, so let's just do solve. Now with that too, if you want to keep it outside the brackets, just put it within 2 brackets like I've just done, or you can expand that bracket. X minus pi on 4. All right, so close your brackets, minus 2. And we're going to be solving for x, so comma x, close your brackets and restrict your domain. So we're going to go to, given that we're going from 0 to 2 pi. All right, I'm going to do that again, but do it in decimals. All right, so we've got x equals 1.808. X equals 1.08. And what else have we got? Oops. Oh, we've got quite a few solutions. 2.65. 5.8. And that was it, just the 3. Just double check. No, I forgot that 4. What that 4? 4.22. And I'll just double check that the last one was 5.8. So 1.08, 2.65, 4.22, and 5.8. Awesome. All right, we'll sketch it now. So let's move that question 11 down. Okay, so drawing our axes first. So because our domain is from 0 to 2 pi, I'm just going to put them in. Pi on 2, 3 pi on 2. Now, if your asymptotes weren't any of them, which they are, okay, so we've got asymptotes at 2 pi on 4, which is at pi on 2. Actually, x is 0 is our first one, so I'll do that, sorry. Then we've got pi on 2, and then 5 pi on 4. I've just realized I've made a mistake because when I did it, I was like, that shouldn't be right. It should be pi. I wonder how many of you actually picked that up when I did it. Probably all of you. Sorry, girls. So that should be 4 pi on 4. The rest are correct. Okay. So I was like, we should be at, you know, if it was symmetrical, it should be there, pi. All right, and there's our other asymptotes. Now, remember your typical tan graph will cross at the halfway point. Now, even if we didn't know what the exact values of our x-intercepts were, so let's say we couldn't use the calculator and realize that they were 1.08, etc., etc. This graph is shifted down, so that means crossing this x-axis, this point is, I might do it in blue. So initially it was here and now it's shifted down. So your graph has gone from this to this. So our x-axis is going to be, sorry, our x-intercept is going to be to the right of that midpoint. Can I get rid of that blue without, no, I can't get rid of that blue without getting rid of the whole line. Just put my x-axis back on. Okay, so we're just going to go a little bit to the right of the halfway point. So I'll put the halfway point back on in green. So there's our x-intercepts just to the right of that halfway point. And we do need to put our endpoints in. So they're at -5, weren't they? All right, so an open circle here at 0 and an open circle here at 2 pi. Oh, now I just realized I made a mistake. Oh, it's so frustrating when I make mistakes on the endpoints, and I knew when I was doing the endpoints that I was doing them wrong, and I did on the calculator. So before I had, and I don't remember doing this, I'm pretty sure I said 2 at the time. I wrote negative pi on 4. It should have been pi on 2, and then we would have got the undefined. So if I go back to my endpoints, oh my God, I'm so sorry, girls. Makes sense that they're undefined. Oops, wrong one. So when x equals 0 and 2 pi, we're undefined because we're actually on the asymptote. Oh my gosh, I knew that at the time. I was a little bit like confused. Okay, so you can see these, and that's not negative 5. Get rid of that. Sorry, that's, oh, my boo-boo. Okay, so we don't need to put those endpoints in because there's no points actually on the asymptote. I can't believe I did that. Okay, so with your tan graph, remember we go close to the asymptote and then we're going to be, oh, that's terrible. We're going to go up like that and we'll do the same for this side. There we go. All right, so there's your tan graph for that last one. Oh my gosh, sorry girls, that was pretty bad. All right, let's finish on a positive note, although this question's not the easiest. But you do need to know the relationship between tan, sine, and cos. So tan theta equals sine theta over cos theta. And I do go through this in a previous video for chapter 6. But you don't really need to remember the proof or anything like that. Just tan theta equals sine theta over cos theta. So for question A, and I might not do too many of them because it's going to be a long video otherwise. All right, so we're going to have, let's just divide both sides by cos. Now the reason I divided by cos and not sine is because you want sine over cos. All right, so then we're going to, when I see sine over cos, that's going to be the same as tan. Okay, so remember tan theta equals sine theta over cos theta, where theta is just a variable like x. So once we've got sine over cos, we can just exchange it for tan. That root 3 doesn't matter. Now remember, fractions when your numerator is the same as your denominator, it's just 1. So tan x is equal to 1 on root 3. So this is where you need to know your exact values, which I don't. So I'm going to scroll up all through those notes. And tan 30. So remember, we don't use degrees, so it's going to be pi on 6. All right, pi on 6. I'm not going to do too many. I think I just said that before. Okay, let's do f, because f has a fraction in it and that might scare you. And I like brackets around my x's, so. Okay, so let's divide both sides by cos. All right, so now we've got tan theta, or tan x, sorry, is equal to 0.5 or half. All right, so a half is not an exact value for tan, so we do have to do it on the calculator. So we just do inverse tan of a half. And when you do that on your calculator, and I just realized because I checked the solutions, I haven't been considering the domain. Silly me. So I had to consider our domain. So I might go back to question A in a sec, but let's do f on the calculator. So you can just do it from the beginning. You don't have to set up the equation like that to put it into your calculator. So sine x is equal to 0.5 cos x, and we're solving for x, so comma x, And we do have to restrict the domain. Wouldn't it be good if there was a button that you didn't have to always do 0 to 2 pi? Now this one is including 0 and 2 pi, so that's why I've done that button, and I need to change it to decimal. Okay, so we've got 0. Alright, so I've just done the solutions there. So 0.05 and 3.19. So if you can't get the exact value, you just use your calculator. Let's just finish off A, and then I'll finish off with the video. So we've only done one solution. So this is where you need to use your unit circle. Alright, so we're looking for tan is positive. So tan is positive here and here. So we've already got pi on 6. The next solution is going to be pi plus pi on 6. So that's going to be pi on 6 and 5 pi on 6 to be within our domain. No, clearly I need to end this video because I keep making mistakes. It should be 7 pi on 6. All right, girls, I'm sorry about the errors I've made, but it is exhausting sometimes writing these videos. Anyway, please make sure if there's anything in the video that you didn't understand that you do ask. Have a go at some of question 11 on your own. Otherwise, the next video will be a lot shorter and a lot simpler because it's not as difficult. All right, bye.